Hi there, and welcome to the first class of our online section of the semester. Today I will do with you chapter 6. In this chapter we will look into consumption, time allocation, and production choices. So essentially we are looking into the households and how the households are making their decisions. As we discussed in the previous chapters, we looked into growth, the different growth models, how can we create growth into a country, and moreover we also talked about poverty, how do we measure poverty. We looked into inequality and how to measure that, and we also looked into vulnerability. Now, it's not that just development happens to the people, but people are a fundamental part of that development and of the system based on their choices. So development can happen faster and growth can happen faster, and also how the benefits of growth are distributed. All of that depends on the choices that people make in markets, but also in non-market settings. For that reason, what we need to do as the next logical step is to look in this chapter into how do people actually make their decision. So we start with the standard model where we assume that people are maximizing their utility, that's their goal. But they also have, of course, constraint, what you can think simply of as like sort of an income. Your income is limited. People cannot buy whatever they want to do, of course. And we also assume for now that people have complete and accurate information about, various aspects, the prices of the markets and things like that. Later we can, relax those assumptions, but for now we are assuming that the market actors have the complete and accurate information. Our goal is ultimately to understand, how consumers are making their decisions. How do the individuals make the decisions, in particular when it comes to consumptions? Based on what factors do they decide if they should spend their money on rice or on vegetable or on other goods, or how much of their money do they spend on shelter, how much of their money do they spend on food, how much on transportation, etc., etc. So this is the goal. This is what we are trying to do here in this chapter. So essentially we are looking into how people allocate their limited income into consumption of different goods and services. And of course we have some assumptions here. So for example, one assumption is that of course consuming more of one good given everything else is being constant is always better. So for example, having more rice and everything else the same, not having to sacrifice anything else to have more rice, is of course better than having less rice. But we also have the law of diminishing returns, which means that the more a consumer has from the one item, the less additional value you get from it. So the first pound of rice per day is very valuable. The second one is not as valuable as the first one. So let's start with some terminologies. So the income is here assumed to be Y, and that income can be distributed into different goods, consumption of different goods and services. So we are assuming here that the income is Y is $1,200, and let's assume that you can either spend your income on food. We call food F, the quantity of food that you consume. The price of food is, let's say, $12 per pound. Dollars per pound of food. And you can also spend your money on other things. Let's on non-food items. Let's say a very poor person can only spend the money on food or shelter. Or you can also assume you live in a planet that consists only of food or shelter, I call shelter N shelter, so non-food items or shelter, to kind of make it easier for you to think of it. Price of shelter is, let's say, $6 per square foot of shelter. Okay, so we have here the assumption that you can spend your money only on food or shelter. Price of food is $12 per pound, and price of shelter or non-food items, here we call it N, is $6 per square feet. Okay, so first of all, what we need is a so-called budget constraint, and the budget constraint is always a straight line that is going from the one axis to the other axis. Now let's assume that on the x-axis we have the quantity of food and the quantity of the non-food. So in this case, shelter is on the y-axis. So food is on the x-axis and non-food is on the y-axis. Now how do we determine the budget line? The budget line is essentially a line that goes from the x-axis to the y-axis. It's connecting those two. So I call it, I made it red. So y is my budget line. Okay, so now the question is, how do we figure out y? Where does y start? Well, it's easiest to look into the two most extreme points of y, and let's figure those out. This is so the connection with the y-axis. So essentially, if I spend all my money on non-food products, and here is on this other extreme is if I go to the other extreme and spend all my money on food items. Now let's take a look. If I spend all my money on food items, how many units of food can I consume? So if I assume I spend all my money on food, we need to do a very simple calculation, and that is the quantity of food that I can purchase. I write it here, is if I spend all my money on if I take my income essentially and I divide it by the price for food, and that tells me how many units of food can I buy maximum if I spend all my money on food and then nothing else. So my income is here in this case $1,200, and the price of food I assumed it to be $12 per pound. $12 per pound. All right, yeah, I corrected the writing a little bit. So what we get is, if we do the math, we see that I can consume 100 pounds of food, which is here the unit. So 100 units of food is what I can consume per period of time, let's say per month. And I can also get the other extreme here, the intercept with the y-axis, and that would be essentially if I spend all my income on non-food products. So essentially I can figure that out by you can make it, maybe pause here and guess how you can figure that out. Yeah, so I'm sure you got that. So the quantity of non-food products, I get it if I take my income and I divide it by the price of the non-food products, and that is essentially the $1,200 divided by what is the price of non-food. It's here. So yeah, the price of the shelter or the non-food product that we are looking at is $6. So $1,200 divided by $6, that is 200 units of shelter, or 200 square feet of shelter in this case, that the consumer can consume per month. So this is giving me the two extremes of the budget curve. On the one hand, if I spend all my money on non-food, I can consume 200, in this case, units of non-food, which is in this case shelter, and the unit is square feet, so I can have 200 square feet of shelter. Or I spend all my money on food, and in that case I would get 12 pounds of food, sorry, 100 pounds of food at $12 per month. Okay, so why is the line straight? Because if you think about it, because for every unit of food that you give up here, you gain how much shelter? Take a look into that. Food is, the price is $12. Shelter, the price is $6. So 1 unit of food that you give up, that saves you $12. For those $12, you can buy 2 units of the non-food product, which is in this case shelter, which means for every unit of food that you give up, you can get 2 units of shelter essentially. Yeah, so yes, the scaling is different on the x and y axis. That's why, so that the 200 looks smaller than the 100, but that shouldn't matter for our purposes. So for every unit of food that I give up, I get here minus 1 unit of food, I get 2 units of shelter, and so on and so forth. So that's why, because that ratio is always constant, the connecting line is essentially a straight line. If I can continue, keep continuing, and so on and so forth until I have given up all my food, so I'm here essentially, and instead I have purchased with all my money just shelter or the non-food product, and that's how I can get to that other extreme essentially. And this line, this budget curve, is representing essentially all the possible bundles of consumptions that I can use. So I messed up the graph right now. Let me fix it really fast. Okay, there we go. So that red line, the budget curve, is essentially representing all the possible bundles of goods and services that I can consume. So essentially every dot on this graph is representing a different bundle of goods and services that I can consume. So for example, if you take a look on this line, for example, why does it not work? Oh, it's because it's on eraser again. So this dot, if this value is, for example, let's say 45 or something like that, and here this value, it would be, let's say 80. Let me erase the thing here on the side, the calculation on the side. Essentially this dot here represents 45 units of food and 80 units of non-food. Or let's say, for example, this dot, 1 second. So this dot would be 200 units of non-food and 40 units of food items. That would be another bundle of consumption. However, this dot, because it's outside of this budget curve, it means I cannot, it's not feasible for me to buy that. It's not attainable. Given the income that I have, I cannot purchase 200 units of shelter and 40 units of food. Remember here, if you see here on the y-axis, if I buy 200 units of shelter, I've already spent all my money. There is no money left to buy 40 units of food. So I would like to have it, but I cannot have it. So essentially every line, every bundle that is exactly on the budget line, that represents a bundle that I would purchase, and that bundle would cost exactly my budget. So I would exactly spend all my money. Anything that's underneath, it means I have still money left, and anything that's beyond is essentially an unattainable budget given the prices and given the income that I have. All right, so I hope that is clear. Now when I have my budget, then I can kind of start with the analysis. So let's assume that saving doesn't play a role here. So let's say we have taken care of saving beforehand. The budget that we have here is solely the consumption budget. So essentially we want to spend all the money, and the saving, as I mentioned, that's an intertemporal budget optimization problem, which we will talk about later in this chapter, so don't worry about it now. The entire money that we have is for spending, and what we want to achieve is to achieve the highest possible utility given the amount of budget that we have here for spending. In our example, it is the amount of $1,200. Okay, so in this example, my budget constraint is a price of food multiplied with the quantity of food that I consume plus the price of non-food, in this case shelter, multiplied with the quantity of shelter, and that must be equal my budget, which is the money that I have to spend. We can do some simple transformation here, so I can say y minus, sorry, let me erase that here and do it again. It doesn't want to erase, it does. Okay, so y minus the price of food multiplied with the quantity of food equals price of non-food multiplied with the quantity of non-food, and then if I divide both parts with the PN, price of non-food, what I would get is that the quantity of the amount of non-food that I consume equals y divided by price of non-food. So my budget divided by price of non-food, which is essentially this thing here. So it's essentially the intercept with the y-axis minus PF divided by PN multiplied with essentially F. So let's take a look. What does it mean? Essentially this line can be described here with the intercept with the y-axis, which is this y divided by Pn, and then the slope of the line is essentially this here, which is minus Pf divided by Pn. So this is my slope, and that's essentially the price minus because as we can see the slope is negative. Pf is the price of food, so the price of the good that is on the x-axis, right, divided by Pn, which is the price of the good on the y-axis. So what we learn here is that the slope of the budget constraint is minus the price of the good that is on the x-axis divided by the price of the good that is on the y-axis, and that is always the case. So essentially the price ratio of the two goods that we are considering is determining the slope of the budget line. So let me clean it up here briefly and write down the important findings that we learned. Okay, so I cleaned it up here a little bit. Essentially what we can say, my y budget line is this equation here, and has the slope of slope which is described by this equation here. So that now that we know that, I can erase this part. Okay, let's assume that something changes and that there is a drought or something like that, and then price of food increases. Price of food goes up from $12, let's say, to I throw in a number, $24. Let's say the price of food doubles. So essentially what would happen here, pause the video and think a moment about it, how the budget curve will change. Give it a thought. How would our new budget curve look like? So if you think about it, this side, when it's on this intercept with the y-axis, Does anything change there? If you think about it, actually nothing should change, right? Because price of non-food has not changed. So this intercept wouldn't change, because this intercept is defined by y divided by price of non-food. Price of non-food has remained the same. Income has remained the same. So it's still 1,200 divided by 6, which is, I can still afford 200 units of non-food max if I spend all my money on non-food. But what happens on this side? Price of food has doubled. The price of food was before $12, but in this new situation, the amount of food that I can consume maximum is my income divided by the new price of food, which is now $24. So it's $1,200 divided by $24 price of food per unit, which is now only equals 50. So in this new situation, I can consume only 50 units of food maximum. That should be somewhere around here, right? So as we can see, our budget curve changes and looks now something like this. Let me see if I can do a proper line here. Yes, there you go. So this is our new budget line, and it is here 50. 50 is the maximum amount of food that I can consume. Maximum amount of non-food is 200. So if you think about it, all these bundles of goods and services that is between my old and my new budget line, this is all the combination of goods and services that I cannot consume anymore. My income hasn't changed. It's still 1,200. And price of shelter didn't change, but price of food, which is an essential good for me, that I can, as a poor person, you spend a substantial amount of your income on food. That good has become more expensive. So for me, it is as if I have become poorer, and you can see it here exactly, because all these possible area, that was all these possibilities of consumption of goods and services, is what you lost now. You cannot consume those goods and services. So here you can see the loss. Okay, so what we see is that essentially the price change of only one of the goods yields to a rotation of the budget line, and the fixed point of rotation is where the price did not change. Of course, there was no change here at this price, so this point remains the same, because it's defined by income divided by the price of the non-food items. So that's the fixed point. But on this end, where the price of food changed, we have essentially a rotation, and the rotation is inward if the price increases, and accordingly, as you can think, the rotation would be outward if the price of food would decrease. So it would be something like that. I hope that is clear for you. Let me do another example for you to clarify it better. Let's go back to our original situation. So food is again $12 per pound and not $24. But let's change now the price of shelter and see what happens. Let's assume that government is subsidizing shelter. Maybe, think of a Section 8 program or something like that, where the government is paying part of your rent and you only pay the remaining amount of the rent. So let's assume price of shelter went down. So let me use purple for this case. Price is now only $4 per square foot. If you think about it, this point, how does my new budget curve look like? I hope you pause the video again and think a little bit about it. And if you think, this point should remain the same, because that's y divided by price of f, and none of the two has changed. Y is the same, price of food is the same, it's still $12. However, price of n has changed, it's now lower. So what we have now is y divided by price of n. Let me erase that. Okay, that is equal, my income is still $1,200, and price of n is now $4 instead of $6, which means I can consume 300 units of n. So the intercept here has gone up. If I spend all my money on shelter, now suddenly I can afford more shelter, 300 instead of 200 units, So let me connect that and let's see what happens. There you go. This is my new budget line. So here, even though my income has not changed, it's still the same. And price of food is the same, but shelter or the non-food item has become cheaper for me. So there is again a rotation of the budget line. This time the fixed point of the rotation is by food because price of food didn't change, and the rotation is this time outward because the price of shelter decrease. If price decreases, there's a rotation outward. If shelter would have become more expensive, the rotation would have been inward, something like that. But that didn't happen. The price of shelter decreased, so the rotation is outward. So that's also important to understand and to remember, because if you think when we look into giving programs where we try to help the poor by subsidizing it, this is essentially what is happening to the poor when they face the subsidy. This happens with their budget curve and so on and so forth. So it's important to understand that the effect, what it does with the budget line. Okay, now you might ask yourself, how does that help me to determine the decision of the consumers? What we learned so far is we can only see what are the possible consumptions of the consumers, how much they can consume given the prices and given their income, but we don't know yet what bundle exactly will the consumer choose, how much shelter will they consume and how much food will they consume. Now, in order to get to that point, I need to introduce you into something else, which is essentially the utility function of the consumer. So each consumer has a different utility function because each consumer is valuing let me change the setting here, is valuing the shelter and food and different products differently because of life circumstances, because of taste, and so on and so forth. So a utility function is essentially a function of the different goods and services that I consume, that is telling me how much do I benefit from having this or that bundle of goods and services. Now, here's an example of a utility function. Let's assume Andrea can only buy CDs or movies. That's everything she can spend her money on. And if her utility function looks something like this, square root of quantity of CDs multiplied with quantities of movies, we can calculate, essentially given the combination of the quantities of CDs and quantities of movies that she consumes, we can essentially calculate how much is her utility. So for example, if she has, let's say, 2 CDs and 2 movies, 2 times 2 is 4, square root of 4 would be again 2, so her utility would be 2. If she has 4 CDs and 1 movie, it would be 4 times 1, 4, square root of 4 would be only 2. So her utility of having 4 CDs and 1 movie would be 2. But if she has 3 CDs and 3 movies, 3 times 3 is 9, square root of 9 is 3. So she would always prefer 3 CDs and 3 movies over 4 CDs and 1 movie. So that being said, let's take a look how a utility function actually looks like on the graph. So I hope you guys read also the book with the slides. So not only just listen to the slides, but also read the book to clarify things more and better for you. So looking into that, the example in the book is not food and shelter. They say instead veggie and rice, but it's essentially the same thing, just different labeling for x and y axis. Okay, so what we learn is that each of the points on the graph, and each point refers to a different bundle, and each point represents a different utility. But as you can tell, if we go towards northeast, so let's compare this point here on the bottom of the arrow with this point on the top of the arrow. The point on the top is more to northeast. At the same time, it means that here, compared to the other point, you are consuming more veggies, right? This means only this many veggies, but at this point you're consuming more veggies. And you're consuming more rice, right? So here you consume only this amount of rice, but at this point you're consuming more rice. So more veggies and more rice. So you have more of everything, which means clearly the point at the where the arrow is heading is associated with a higher utility than the point where the bottom of the arrow is heading. So let's take for example 2 points here. This point I have this amount of shelter and this amount of food. Now I can take away a unit of shelter, let's say this is a unit of shelter, from this consumer, and I can compensate that consumer with exactly the amount of food that makes the consumer just indifferent between this bundle and that bundle. So what happens here is that I take away shelter from the consumer and I give to the consumer just the amount of food that makes him exactly indifferent between this bundle and this bundle. So the consumer, if I would ask him which one do you prefer, he would literally say, I really am indifferent. They're both equally well to me. So, and I can keep doing that. I can take more shelter from that person and compensate that person with more food to make him again indifferent, and more and more and more. So I can play that game with all different kinds of combinations. So every point of this combination essentially is giving the consumer a utility level of, let's say, 10 or something like that, right? Now, if you remember from the slide, as I told you before, let's compare 2 points here. Let's compare this bundle, for example. This bundle, let me see, this bundle and this bundle here. Clearly this bundle must be better than that. So this is bundle A and this is bundle B. Bundle B must be definitely preferred to bundle A. Why? Because you have more shelter and you have more food. So you have more from both. So clearly as you go to northeast, you must be better off. What does that mean? That means that, for example, bundle B is also on another indifference curve, which means that bundle B is here on a different indifference curve, because I can again start from bundle B and again take away shelter and add just the amount of food that would make the person exactly indifferent between this and that bundle. I don't know why it keeps erasing it. And I can take again more shelter but add again more food to compensate the person. Any point on this indifference curve, and the pinkish indifference curve, is preferred to any point on the purple indifference curve, because there's a utility of 20 on the pink utility curve versus a utility level of 10 on the purple one. So let's go back to the slide. Essentially here you see a selection of different utility curves, and as you see, each of them is representing a different level of utility. So there's a utility level of 10, 20, and 30. This way we can see how well is a consumer doing with any given bundle of goods and services, any bundle of consumption. Okay, so let's take a look on this indifference curve. If you take a look here, it's curved, it's convex. Let's take a look on this point. The person spends a lot of money on non-food in this case, and very little money on food, so consumes very few food items and a lot of non-food items. So assume to live in a very big, nice, fancy place, but the rent is so much that you don't have much money left to spend on other things, to eat food or something like that. Now it's nice to live in a large place, but it is not that nice to have not so much money for food and other things left. So let's take a look here. You can take away quite a lot of the shelter from that person, right? So instead of 3,000 square feet, you can tell him, hey man, you live in only 2,800 square feet. So you can take away from that person entire 200 square feet and give just somewhat more food, and that person would be indifferent between this bundle and that bundle. So even though he loses quite a lot of space, but gains not that much food comparable, because having 3,000 square feet versus 2,700 square feet doesn't make that much of a difference. Whereas if you're in this extreme, in this other end, so here the person has only 350 square feet, let's say, of housing, but has a lot of food, then having the fourth pizza of the day is probably not that exciting anymore. You would certainly not give up 300 of your 350 square feet. You would certainly not give up 300 square feet for another pizza or something like that, or for more food. So that's essentially why the curve is here. So if you have a lot from the one good, you would be willing to give up quite a lot of that to buy more from the other goods. So it has to do with diminishing marginal utility of having one product. Okay, now knowing the budget line and understanding the budget constraint, and also knowing the indifference curves, we can now find the optimal budget of consumption for our household or the person that we are considering. So let me draw an indifference curve here. So this would be the indifference curve, and as you see, parts of that indifference curve is not within the budget line. So this area of the indifference curve is essentially unattainable, but that doesn't matter really. The reason it doesn't matter is that there are other parts of that indifference curve where that I can achieve. So for example, these parts are all attainable for me, and a point here is for me just as good as a point there where it's unattainable. So that is good. So I can definitely achieve that level of utility, but that's not our question. Our question is, what is the highest level of utility that I can achieve given the budget constraint that I have and given the indifference curve that I have? So if you take a look, there are two intersections here of that indifference curve with the budget line. One is here and one is there. I don't know why this thing is erasing my arrows. These are supposed to be arrows, okay? So that being said, if you take a look, if you consume that bundle, you spend all your money and you achieve that level of utility. However, why not spending, for example, choosing this bundle, where this bundle is giving you the exact same utility as the ones that are crossing the line, but as you see, you have some money left because you're not even at the line. So if you start, for example, from the bundle here that I will mark with red, I can buy here this bundle, which is, for example, I don't know, 50 units of food and maybe 40 units of shelter or something like that. I can spend more money and I can buy more from food and from shelter. So it means I can add to my utility, which means I can move on a essentially higher indifference curve. Let me draw that for you. So for example, I can move to this point on a higher indifference curve. So what we learn is that if there is space between some points of indifference curve that is within the budget line and the budget line, it means that I'm not at the optimum, because I can choose that point and I can buy more from good X and from good Y, and I can definitely be on a higher level of utility. So now I'm on a higher level of utility, but as you see, I'm facing the same problem or the same situation. I can do even better than that. So I can spend also more money here and move on a higher and higher. So essentially I can take it to the extreme, and the extreme would be if there is no space left. So essentially there's just a point of tangency between the indifference curve and the budget line. Let me redraw the indifference curve to have it a little bit nicer. So something like that. So here there's just a point of tangency. There's only one point of tangency, it doesn't cross, and that is my optimal, exactly my optimal bundle of consumption. it must be on an indifference curve that has only a point of tangency that does not cross the budget line. These ones are crossing. So if an indifference curve is crossing the budget line, like at this point, then this cannot be the highest level of utility that I can achieve. I can certainly do better than that. So I hope that you understand this, because this is really important. So I can erase all the unnecessary ones, and yeah, this is the one that we have. Okay, so yeah, this is the optimal bundle of consumption. It's the point of tangency between the indifference curve and the budget line. I hope you understood this very good, because the entire chapter 6, that entire analysis, is based on this concept. This is the tool that is helping us to understand how consumers are making the decisions, and what are the determinant factors of how many units they buy. Essentially, from this concept, we can even derive the individual person's demand curve, and by summing up all the individual person's demand curves, what we get would be the market demand for the goods and services. I will come up with follow-up videos to explain further concepts.